Hi guys, tonight's video is going to be an introduction to section 3.12, slope as a rate of change. Now, as you all remember, to find slope, you just use the slope formula, m equals y2 minus y1 divided by x2 minus x1. And if you're having trouble remembering, you can either watch the video I've included on the channel, or just look right at the top of your screen there, and you'll see I've included it. Now, when we talk about slope as a rate of change, the most common rate of change that we run into is speed. Now, speed is simply the rate at which distance traveled changes, which sounds fancy and mathy, but all it really means is how fast you go. The higher the rate at which your distance traveled changes, the faster you're going, the higher your speed. Let's look at an example. Over to the right, you'll see a time distance graph with my x-axis going from 0 to 2 in hours, and my y-axis going from 0 to 100 in miles. Now, as you can see, the rate of speed, the rate of change, is not consistent. You can see that it's very steady, a very constant change from 0, 0, the origin, to point P. Then you can kind of notice an actual curve going up from P to Q, and then a flat horizontal line from Q to S, and finally a pretty steep line from S to U. So obviously, if we wanted to sit there and calculate each individual slope, each individual speed, we could do that, even down to the second if we had a good enough graph and we had the data to do it. But we don't want to do that. So for this situation, I want to start just by calculating the average speed for the entire trip. Okay? So let's first collect our points to plug into our equation. And if you're going to take the average speed for an entire trip, you need only the start point and the end point. And if you're ever driving anywhere, your start point is going to be at 0, 0, down here. And your end point, in this case, is point U. And that is located at 2, 100. So first, let's collect our point data. So I'm going to call the origin or the start point O, and that's at 0, 0. And then we have point U, which is 2, 100. So now that's all that's left to do to solve this is simply plug it into our slope formula. So we'll take our points and we'll label them. So we have x1 and y1, and then we have x2 and y2. And now we just plug them in. So our y2 is 100 minus our y1 of 0 divided by our x2 of 2 minus our x1 of 0. And we end up with 100 over 2. And you can reduce that to 50 over 1. And now what this is basically saying, for every 1 hour we travel, we will be driving 50 miles. So even though we had all these crazy changes from a constant slope to a curve to a flat line to a steep rate of change, all it's saying is that over the course of the whole trip, regardless of all those changes, our average speed was 50 miles per hour. Now, I'm going to show you a couple of examples with this graph in the next video on how to calculate between the intervening points and what that can tell us. But for now, this is a good start and it'll get you going. All right, guys, see you in the next video.